What is Young's modulus? The concept of Young's modulus is the property of a material that discusses how it can be stretched or deformed. Young's modulus is represented by the formula stress over strain. Stress is force over area. In this case, area is represented by the cross-sectional area of the resistance band. Strain is initial height over final height. Experiment process. Materials. Ring stand, something to hold. In the experiment, a makeshift wooden stand was used. Glue stick, or a materialistic object that can be weighed. Scale and resistance band. Method. Begin by placing the resistance band on the stand demonstrated in the video. Then, weigh the glue stick. Measure the resistance band initial height. Place the glue stick within the band and measure the final height. Forgot to mention in the video, measure the dimensions of the resistance band.
Based on the previous slide, you will use your ring stand or your wooden stand and place your resistance band like so. You will then take your ruler and measure out how many centimeters it is. Mine is approximately 21 centimeters. Convert that to meters and that will be 0.21 meters. That is your initial height. You will then take your glue stick or your material that you will be weighing and weigh it. The glue stick is approximately 42 grams. You will then place your glue stick or your material and place it inside the resistance band like so. You will then measure how many centimeters it is. Mine is 23 centimeters, so that is 0.23 meters. And that's the end of the experiment. Thank you.
Calculations and findings. The Young modulus of the band is 86,435.9 pascals. The band stretched 0.02 meters. Calculations are on the next slide. To start the calculations of the Young modulus of the band, we'll begin with the formula stress over strain. Breaking it down where stress is force over area, force which is mass times acceleration, we'll begin with that. Since the mass of the glue stick is 42 grams, convert that to kilograms to meet the appropriate units. Then multiply 0.042 kilograms by 9.8 meters per second squared, which is acceleration due to gravity, to find force, which will be 0.4116 kilograms meters per second squared, which is newtons. Then find the cross-sectional area of the band, which is width times height. The width of the band was 0.05 meters and the height was 0.001 meters. Multiply the two, you will get 0.0005 meters squared. Then, calculate stress by dividing the products 0.4116 newtons divided by 0.0005 meters squared, which is 8,232 newtons per meter squared. Then you will calculate strain by finding the change in length, which is final height minus initial height, which was 0.23 meters minus 0.21 meters, which is 0.02 meters. Then, to find strain, divide the quotient by the initial height, which is 0.02 meters divided by 0.21 meters equals 0.0952 meters. Thus, 8,232 newtons per meter squared divided by 0.0952 meters is 86,435.9 pascals, and that is the Young modulus of the band.